Hello everyone. Today in this PPT we will be doing the unit 2 transducer. We will be continuing that unit with lecture number 6. It is from the subject electronic measurement and instrumentation. So first let us see the contents. We will be doing today Hall effect, then Hall effect transducer, then current measurement, fluid level measurement, then LVDT, then advantages, disadvantages and applications of LVDT, then thermistor, then at last we will be doing the summary. So first, Hall effect. So what is this Hall effect? When magnetic field is applied at right angles to the direction of electric current, and electric field is set up which is perpendicular to both. Okay, then an electric field, this phenomenon is nothing but it is called as the Hall effect, named after what it is? It is named after the scientist. Okay, so the Hall effect may be used to find whether semiconductor is N-type or P-type to determine the charge carrier concentration. Okay, so you can see over there this here the magnetic field is applied at right angles. In the diagram you can see the magnetic field, it is at 90 degree. Okay, right angles. The next one, Hall effect transducer. Okay, so here this are transducer in which Hall effect is used to measure various electrical and non-electrical quantities. The following are the applications of Hall effect transducer. So Hall effect displacement transducer, first one we will be seeing. The Hall effect element may be used for measuring a linear displacement. Okay, you can see over there the force of magnetic plate, the displacement. Okay, the Hall effect element is located in the gap. So in the gap the Hall effect element is located in the gap of that structural element is there, no, then permanent magnetic gap is there, it is there, Hall effect element. Then next, due to the permanent magnet the field strength is produced in the gap. So there is a permanent magnet, due to that magnetic field there will be what? Field strength. Then field strength is changed by changing the position of ferromagnetic plate. So you can see there ferromagnetic plate, the displacement it is written there, no, here there we will be what? Moving it. Okay, due to that movement position the field strength is changed. By this proportional output voltage is produced. So how much you will be doing the changes over there, due to that the output voltage will be produced. Okay, then next one we will be seeing current measurement. Okay, next application, Hall effect transducer is used to measure current in a conductor, so without disturbing the circuit. So we will not disturb the circuit, without disturbing that we will be seeing measuring the current. So without making electrical connection between the conductor, circuit and the meter, you can see in the diagram as shown in the figure, when DC or AC current flows through the conductor. Okay, so current carrying conductor, okay, wound around the core. So that current carrying conductor, that wire is wound around the core. The magnetic field is proportional to the current. So whatever the magnetic field will be produced, it is proportional to the current. A Hall effect sensor is placed in the slot. You can see the Hall sensor in that slot, particular slot it will be placed. The voltage produced at the output terminal is proportional to the magnetic field strength, and hence is the proportional to the current flowing through the conductor. So that current carrying conductor, it will give what? The when we apply the current, it will produce the magnetic field. So depending on that magnetic field strength, you will get a proportional current flowing through the conductor. Okay, so like that current is measured. The next one, fluid level measurement. Okay, so here we are measuring the fluid level of it. So figure shows the Hall effect transducer can be used to measure fluid level in an automobile fuel tank. Okay, a fuel level indication can be obtained with a Hall effect sensor by attaching a magnet to the float assembly. So we will be attaching a magnet over that, okay, to the float assembly. You can see in the diagram, as the float moves up and down with the fuel level, the gap between the magnet and Hall element, so this Hall sensor will be there and magnet, so gap between that it will be as and well the water in that or fuel in that will be reduced or increased. The gap between that, it will be increasing or decreasing. So due to the gap between the magnet and the Hall element will change. Okay. So this gap change the Hall effect and thus the output voltage. So depending on the gap changes, there will be change in the output voltage and you will get the fuel level measurement. Okay. Fluid level measurement. The next one, LVDT, that is nothing but linear variable differential transformer. Okay. So this linear variable differential transformer, you can see over there in the diagram, the LVDT, it will work under the principle of what? Mutual induction. Okay. Then next, it is used to translate the linear motion into electrical signals. So whatever the soft iron core is there, no, that it will be moving by the arm, we will move it. Due to that movement, what will happen? It will translate that linear motion into electrical signal. So you can see over there in the diagram construction, LVDT, what it consists of? Cylindrical former when it is surrounded by one primary winding in the center of the former and two secondary windings at the sides. So primary winding will be in the center and besides it there will be two secondary windings. Okay. Then the number of turns in both the secondary windings are equal, but they are what? They are opposite to each other. Okay. The net output voltage will be difference in voltages between the two secondary coils. So output voltage, what it will be? It will be difference between the voltages between the two secondary, because they are opposite to each other. The two secondary coils are represented as S1 and S2. You can see in the diagram S1 and S2, that is the secondary coil. An iron core is placed in the center of the cylinder former, which can move in the motion. So that iron, as I told you, soft iron core is there, with the help of arm it can be moved. Okay. The AC excitation voltage is 5 to 12 volt and the operating frequency is given by 50 to 400 hertz. So how it will be working? An AC voltage with a frequency between 50 to 400 hertz is applied to the primary winding first. Then two voltages VS1 and VS2 are obtained due to that at the two secondary windings S1 and S2. The output voltage will be what? Difference between the two voltages, that is VS1 minus VS2 it will be. Okay. Then we will be considering, let's consider three different positions. We will consider first one null position, then right of the null position, then left of the null position. Okay. So here next we will be seeing null position means what? It will be balanced one. Okay. Then right of the null position means they will be to the right side, moving to the right side, and left null position will be, they will be to the left side. Okay. Depending on that you will be calculating. The next one, advantages, disadvantages and applications of LVDT. Advantages of LVDT: high resolution, high output, they will be having high sensitivity, very good in linearity, rigidness, less friction. Then what are the disadvantages? Very high displacement is required, then shielding is required, then it is greatly affected by what? Temperature changes. Then the performance of transducer gets affected by vibrations. Then applications where it is used: LVDT can be used as a device to measure force, weight and pressure. Okay. The next one, thermistor. So this word thermistor is a contraction of the words thermal and resistor. It is what? It is a temperature sensitive semiconductor device. Okay. So whose resistance varies with the temperature. So temperature, these thermistors are transducers which are thermally sensitive variable resistance made of semiconductor materials. A thermistor is a type of resistor whose resistance will depend on what? Temperature. It exhibits high negative temperature coefficient of resistance. So the diagram you can see over there, that is the thermistor. The next, application. So first we will be seeing first negative temperature coefficient of the thermistor. So there are two types of thermistor. First one is NTC, that is negative temperature coefficient. It is the resistance decreases with increase in temperature. Okay. So the resistance decreases when the temperature increases here. Then positive temperature coefficient, that is PTC, the resistance increases with the increase in temperature. Okay. Then applications of thermistors: measurement of of temperature it is used, then for measurements of level, flow and pressure liquids. Okay. Then summary. Hall effect transducers are used for measuring various physical quantities such as displacement, current, magnetic flux, field level and fluid level. Then the principle of operation of LVDT is based on variation of mutual inductance, and a thermistor shows change in resistance with the change in temperature of the environment. Okay. So by this we are completing this lecture. Thank you.